Hello, everyone. The blockchain industry is transforming the entire landscape. It's a major transformation, although it started almost like 10 years back. It's in its infancy. There are lots of interest that is getting generated now, especially with respect to cryptocurrency investing. In today's video, we will talk about the blockchain. Before we begin, I would like to just introduce myself. I am Santo. I run the Twig, where we believe anyone can invest. You can understand more about us and what we do by visiting thetwig.com. We are primarily focused on investing in shares. We provide educational and informational data around investing. If you want to know more about us, you can also visit our About Us page. We have a single-minded mission to make investment simple. We believe anyone can invest, but most of us don't. The reason we started with this topic of the blockchain was to first really understand as to what is blockchain. So anybody who's wanting to get into investing in cryptocurrency, the first question that comes into the mind is what's Bitcoin or what's blockchain, and that's where lots of people are still in the mindset that it's speculation. There's lots of hype in the industry, and there are lots of question marks with respect to what this is all about. Before I delve deeper in, I would like to acknowledge the fact that I'm not a financial advisor. So you need to do your own research. You need to interact with your own financial advisor if you want to take any decisions. This entire video and the content in the channel is for informational and educational purposes only. So what is blockchain? I'll give you an example of what a database is so that you can relate to what a blockchain is all about with an example of Excel sheet. So what you see on my screen is a couple of information that I've stored in an Excel, right? So I've written store and write, and once I save this file, this information gets stored on this Excel sheet. So from that perspective, is nothing but a database. And what a blockchain is, it's essentially an extension of that concept, where on a larger scale we store information, and as I said, information is nothing but data, and that information, once it gets stored, it resides on the blockchain. Let me expand this concept further, right? So what I just said was blockchain is a database that collects and stores information. So what kind of information does it store? So if you take the example of, say, a bank where you have a deposit or a savings account, if you look at the statements that you get generated from the bank, you would see transaction activity along with the credits and debits. That form is nothing but when technology was not there, people used to still record any transaction that used to happen between different parties, right? And that used to be written in books of paper. This concept that I was talking about of the paper ledger, that evolved to ledger, digital ledger for a centralized bank, for example, and now comes blockchain, which is an evolution of that digital ledger. In summary, what is a blockchain? Blockchain is information captured in a database. It's an underlying technology that enables it. So that there's a complete framework or a protocol that is behind how it essentially works, and it's in the form of a digital ledger, right? So where transactions made in Bitcoin or digital currency is recorded. Now, having understood what a blockchain is in its very simplistic form, let's deep dive into understanding as to how a blockchain really functions. What I've done is depict a pictorial representation of a blockchain that you can see here on the left hand side. At the core, I mean the core or heart of a blockchain is data, right? So I was talking about a blockchain being a database, essentially a distributed ledger which records transactions. So where are these transactions stored? So these transactions are stored in these data blocks that you see, in these cubes that you see. So multiple transactions could potentially form a block, right? So when transactions happen within the blockchain network, each transaction gets added on top of each other, and once it reaches a certain threshold, it essentially forms a block. Now this block is the fundamental to how blockchain works. But what I'll do here is I'll try and connect this story to what you see on the 5 different characteristics of a blockchain, which I've depicted on the right hand side, because this will actually help you understand blockchain much better. All right. Now, going back to the previous diagram, let's imagine that a number of records have come together to form a block. Now, what happens in blockchain is there are multiple blocks like that, right? So 50 transactions could form a block, another 50 forms another block, and so on. Now, each of these blocks are connected to each other. So that's where you see this connection between first block and then this is the second block. So I'm calling the first block Genesis block because it's the first block in sequence. And the first block is connected to the second block. I'll come back to as to how the connection works and the details and mechanics of it. But just to keep it simple for now, understand that whenever a transaction happens, the transactions get recorded in a sequential fashion, one after the other. And once it reaches a certain threshold, it forms a block. And that block is connected to the next block, and so on. So the second block is connected to the third block is connected to the fourth block. So these blocks, which are connected to each other, they form the ledger. Each of those blocks are connected to the next one in such a way that you can retrace the path. So going back to the characteristic that I was talking about, see, one of the key things that you see here is, and the way the technology has been built is, you can't delete any transaction. So anything that is recorded on the blockchain is permanent from that point of view. Right, so I'll just repeat, any transaction that is recorded on a blockchain cannot be deleted. It can be modified, it can be changed, you can add transactions, but you cannot delete a transaction. Imagine a book as well, right? So if a book, if the moment you remove a page, it's very easy to understand that the book has been tampered with. The moment there's any tampering, any modification, any change that happens, it can be very well easily known because of the fact that each transaction is sequential in nature and every block is connected to each other. Just like if you remove a page out of a book, it's easy to find out that the book has been tampered with. Now, the other important thing to notice is the facet of consensus and decentralization. So as I said, this is a complete ledger that you see here, which are multiple blocks of data connected to each other in a sequential fashion. Now, this forms a blockchain, right? And this blockchain is actually shared with the miners. A copy of the blockchain is shared with the miners. A miner could be a server, it could be a computer, it could be even a MacBook, essentially a device which can perform certain operations, right? So this blockchain is shared with the miners, and the data is also shared with the nodes. So nodes are again nothing but computers who have a certain functionality. Any transaction that comes in needs to be validated by somebody to say that yes, this transaction is right, and that validation essentially is done by these nodes. So there are several nodes in the network. I mean, anybody can apply to be a node. Currently, there are multiple nodes like that, and all of those nodes have to agree, which is where the consensus mechanism comes in. have to agree that the transaction is valid for the transaction to be included within that block. And the consensus happens only when at least 50% or more of the nodes agree on that fact, right? So this is an important concept that we need to understand. Now, this ledger or the entire blockchain, as I said, is shared with two different parties, the miners and then the nodes. I mean, how does a miner or node essentially work, right? So as I said, it could be a server or a computer, but they have specialized software which does certain functionality. At the end of the day, any server, any computer, a group of computers, a large data center could function as either a miner or a node, as long as they have a required software installed on their machines. Right now, what is the difference between a miner and a node? So if you notice here within this diagram, there are two set of things that we talked about, right? So one is any transaction that comes in, gets added to the blockchain, needs to be validated, right? And that validation essentially is performed by the node. And how do they perform the validation? They perform the validation because they have a copy of the blockchain, and each of them are able to verify that the transaction that has been entered is valid, and they agree on it. And once they agree, that transaction gets added to the blockchain. The addition of transactions to the blocks is one concept, and then the creation of the block itself is another, right? So once a set of transactions are added to a block and the block reaches its size limit, then no more transactions can be added to it, right? Because the size limit has been crossed, and that's when a new block needs to be created. Now, this function of creating a new block is performed by what we call a miner. So miner has a specialized software which enables them to create a new block. Now, why will somebody do these functions, right? So when I say somebody, why will somebody deploy their computer or data center or large servers to perform the activities of the validator, which is the node, or the miner, which is creation of the block, unless somebody has an incentive or a reward for it, right? And that is where the concept of rewards come in. So the work that a miner does to enable the creation of the block is called proof of work. So they have to do certain activity to ensure, and I'll come to that as well in terms of how the block is created. But essentially, they have to perform a set of activity or solve a puzzle. I mean, to make it simple, they solve a cryptographic puzzle to enable creation of a block. And for solving that puzzle and enabling the creation of the block, they are rewarded with a certain token, which in the case of the first blockchain, it was Bitcoin. I'll finally come to the concept of security. I mean, so we talked about several things till now. We have talked about the data cannot be deleted. It talked about the fact that they are recorded in a chain. There's a consensus which is required to ensure that the transactions are accepted, and there's also consensus required for a block to be created as well, right? So it's not easy for any transaction to be accepted just like that, because at least 50% of the miners and 50% of the nodes have to accept either a creation of a transaction or creation of the block. But the most important concept which provides the maximum security in a blockchain is the mechanism of creation of the block itself, which is done through a cryptographic hash function. To get a better understanding of how cryptographic hash function is used to secure the entire blockchain network, it's used to create those blocks and the process of doing so. It's important to understand what is data, right? So that's what we'll be talking next. If you look at this representation, what we have shown is the various data elements within each of those block. The first block we have called it as Genesis block, which is the term used in blockchain because it's the first block. It is essentially the Genesis block. And then you have block 1 and block 2. Now there are different elements within each of those block. I'll explain a little bit more in detail in terms of what it is. The first one is a magic number. A magic number is a constant value. I mean, yes, it tells us what that blockchain network is, right? It's a constant across the blockchain network. It's a constant value. The second data element is the block size, which determines essentially how many transactions can be recorded within that block. And once that block size limit is reached, the transactions will start getting recorded into the next block, right? So that's what is block size. Version is the version number of the Bitcoin protocol that is running across all the nodes. So as I said earlier, the nodes are the ones who validate whether those transactions are accurate or not, and they are the ones who accept the transactions. So all of those nodes need to be running on the same version of the Bitcoin protocol. All right, so that's one mechanism to ensure that there's consistency and consensus across the network. I'll come back to the previous block hash and Merkle root a little later. Then we have the timestamp. Timestamp is essentially the date and time of the block creation. It provides a record of when the block was created. And then we have the transactions itself, right? So transactions will be recorded in a sequential fashion, and we also need to identify the number of transactions within that block, right? Because based on the size, the number of transactions within each block could be a little different, because the size of each of those transactions could be a little different as well, right? So we need to record the entire list of transactions, and we also need to record the number of transactions which are within that block. Now, what is Merkle root? Merkle root is essentially it's a fingerprint, a digital fingerprint of all the transactions. I mean, it essentially summarizes the transactions in a digital hash function format. I mean, I'll not talk about how the Merkle root is generated here, but the important concept to understand is the hash function concept, which is where, so if you look at the Genesis block, since it's the first block, there's no previous block hash. What we call is the hash number, right? Because the hash number for a Genesis block is 000. Now, for the second block, there are two numbers that is stored. One is the hash of that block and the hash of the previous block. And that's how the first block and the second block is connected, right? Because within the block 1, you have the hash number of the Genesis block. Similarly, if you move to block 2 has the hash number of its own block, and it has the hash number of its previous block as well. Now, what is this hash that we are talking about, right? What is this current block hash? What is this previous block hash? Hash is a cryptographic mathematical function. The mathematical function can have an input and an output, right? Now, whenever you provide an input to this mathematical function, it generates a fixed size output, right? Now, for any input of the same value, the fixed size output is always a constant. Now, the moment you change the input, the fixed size output will change. So this mathematical function has certain unique characteristics which makes it very important for security, right? And it's used across different networks to secure information. And one of there are the different protocols followed in cryptographic hash functions, and one of them is secure hash algorithm 256. I'll shortly show you an example of how that is created. It has four main features. One is any certain input always produces the same output. So the input has the same output. Now, the second thing is it's difficult to, it's really, really difficult if you know the output to figure out what that input might be, right? So you have to do lots of permutation combinations to figure out what that input was which generated that output. And this is because there's no way to have the information about the input if you're given the output. So basically, if you're provided the output doesn't have any information within it which can reveal the information about the input. So the only way to get that information is through lots of permutations combination, figuring out to multitude of say inputs to see out which one generates the output, right? That's the third important characteristic of the cryptographic hash function. And the fourth important characteristic is it's essentially impossible for two inputs to create the same output. So no two input can generate the same output. You can learn more about the hash or the cryptographic hash mathematical function by referring to the Investopedia article. I can provide a link back down below. And I'll just quickly show you an example of how the hash is calculated, right? So this is a link where you can provide the input, which is the data that I was talking about, and this is where you'll get the output. So let's say blockchain is fun, and let me calculate the hash. So what you see is a specific number that got generated. So I'll just capture this number that got generated and store in text pad here. Now, and also I'll just for my reference, I'll just capture this data as well. So if you look at it now, if I enter this number as the data now and recalculate the hash, it generates a completely different random number, right? So there's no way I can figure out what was the source of the input data based on the output that I'm given. So if I'm giving this output, I don't know what the input is, right? Unless I do lots of permutation combinations to figure out, going through multiple such words, sentences, to figure out what this output might be. Right now, instead of, let me go back and say, instead of blockchain is fun, I just write I am crazy, right? Now what happens? It generates another number. It's a completely different number, right? But if I go back and enter this blockchain is fun, it gives me the same number, right? So the blockchain is fun it always gives me the same number. So what it means is there is a mechanism to validate through permutation and combination, saying what the input is for a defined output, but it requires lots of effort, lots of permutation and combination to be able to generate, to be able to find what that input is for that particular output. So this process is actually involved in the creation of that block. Which makes it really, really difficult. So how does this cryptographic hash function is implemented to create the blocks? I'll explain through this diagrammatic representation here, which is through a link through an article on Medium by we have Kiran Vaidya. So what you see here is three different things that is involved in generating the hash number. The first one is something called nonce, which is a number which is generated only once. So whenever a block is created, the block automatically generates a number which it uses to add with an input string to generate a hash output. So what you see is, for example, when the first block gets created, what it will do is it will randomly generate number 1, it will add an input string. So this input string is nothing but the data within that block. If you remember, a block gets created, and only once the entire block is filled with the transactions up to the maximum size that is allowed within that block, that's when the process of creating a hash for the block gets started. And in that process of creating the hash, essentially what is used is the data within that block, including all the transactions and the transaction counter and its digital fingerprint, as well as the other details that are shown as being component of the data block. So that's what is the input string. The objective of adding this input string with the number 1 and hashing it to get a number is to find that number which meets the difficulty criteria. Right, so what you see, it starts off with a difficulty level of 1, which essentially means it needs to look for a hash function which has 1 leading 0. So 1 leading 0 means it has to have 1 0 at the start of the hash function. So when it starts with number 1, it adds an input string and then it does hash on it. So if I go back to the earlier example, I just say 1 make, what was the data there? Make America great again. Was that right? And I do a hash function, so I get this hash, right? Which is the hash function that we see here. Now this hash function will not be accepted by all the miners because it doesn't have a leading 0. So the expectancy of that block is the hash function that is generated has to have a leading 0. So what it does then, it increases the nonce by 1 more and tries that process again. So what it does, it adds 2 to make America great again, tries the hash function again to see as to whether it gets a leading 0. And it continues to repeat that process multiple times until it finds the leading 0, right? So once it finds the leading 0, it announces, basically the miner will announce it, broadcast to the rest of the network, saying that it has found the golden nonce. This number is called the golden nonce. When it finds the hash number with the required level of difficulty, it essentially means that it has found that golden nonce. It announces to the broader network, and they all accept. They are able to validate that yes, this 20 with Make America Great Again gives this number which has the required difficulty. So then the block gets created. And when the block gets created, the block now has this as the hash number, right? Now what happens once that block has been created, right? So that becomes the hash number. Then the process of creating the next block starts happening. So transactions starts getting inserted. Once the transaction has reached the maximum size limit, then the miners have to start looking for the next hash number for the next block. Now how do they do that? Now for the next block, the difficulty number is increased. The difficulty number is no longer 1, and that makes the process of generating the next block much more difficult, right? So as you see here, what happens is the system, the protocol automatically increases the difficulty level to 2, and then the next block starts adding the nonce from 21, because in the last block it had 20 when it found which was the golden nonce. So it starts with 21. Now when we do the hash function, it needs to generate a number with leading zeros as 2 in this case. So for example, if I start with 21 here, I do the calculate hash function, it doesn't have the leading 0 as 2, right? So it will continue doing it till it generates again a number which is the golden nonce with 2 leading zeros, and this becomes the hash number for the second block. So this process of generating the hash number using nonce and the at a required level of difficulty is what is used to generate nodes. And what you notice here is this process becomes very difficult, right? So because they have to go through lots of permutation combinations to find the right hash with the right amount of leading zeros. Now, as you see in this article at the end, if you see if they have found the second block and then the third block, once the difficulty level reaches 4 zeros, the first such occurrence when the hash is reached with 4 zeros happens only after 69,817, and it just keeps on increasing exponentially. And that is why the process of generating a block is so difficult. So now let's come back to the structure that we talked about, right? So I explained as to what the cryptographic function is. We talked about how the hash function is generated and is connected to the previous hash. So essentially the block has the hash of the current block and it has the hash of the previous block as well. Now, how is it secure, right? So one is the process of creating the block itself, which is very cumbersome. I mean, it's essentially the miners have to solve a puzzle, which is not easy to do, where they have to go through multiple permutation combination to reach a certain number. But nowadays, the chips that is being manufactured is very fast, right? So the computers are becoming very fast from that perspective. So what essentially the protocol has done is they have defined a minimum minute which is required for generating a block. So no block can be generated within less than 10 minutes. And that's where the next bit of security comes in. So for example, when I talked about the fact that the transactions can be added, but it cannot be deleted or changed. Now let's assume a transaction gets changed within one particular block. Now the moment a transaction changes, that means the block has changed, because the hash function is based on the data within that block. Now assume any block, there's tampering or change that happens on any of them, right? So let's say in this instance, if the tampering happens with the second block, the moment the tampering happens, the hash of the block has to be redone, because if you have generated the hash, that means it's a finalized block. But the moment you tamper with it, you make any change, that means you have to redo the hash. And if you redo the hash, you're no longer connected with the other hashes because the hash number has changed. So for example, in this case, the second block will not have this same hash number. So if it doesn't have the same hash number, now it's no longer connected to the third block, because the third block had a hash number which was different from the hash number for the second block. So in that case, what happens is all the miners, I mean, basically, if somebody has to tamper with the entire blockchain, they have to ensure that every block gets generated within that blockchain. And that process is difficult because generating one block takes 10 minutes. So if there are multiple blocks within that blockchain, to create the entire blockchain will take 10 times the number of the number of blocks within that blockchain. That's why the process of tampering with the data within the blockchain is so difficult. And on top of this difficulty level, I mean, within the blockchain protocol, what it essentially does is it uses a mechanism of double hashing. So rather than a single hash, it uses double hash. The reason being because the computers nowadays are much more faster. So there's always a risk of two different miners at the same time finding the same hash, which it can create a situation where two miners are creating blocks at the same time because they have found the same hash at the same point of time. To prevent that, there's a mechanism of double hash instead of a single hash. So if you look at the entire cryptographic the puzzle solving mechanism of generating the blocks, it's almost impossible to essentially tamper with the data for a blockchain. And that is why the blockchain for the Bitcoin network has never been tampered with for the last 10 years. It has never been hacked. And that's all for today in this topic of what is blockchain, demystifying blockchain. I hope you liked the explanation. If you have any questions, any queries, happy for you to reach out to me at invest@thetwig.com or santo at reesa, reesaa.com. Just to conclude and just to remind all of you, I'm not a financial advisor. The content was just provided for information and education purposes only, and I would request you to look at your own financial advisor for your own personal circumstances and make the right investment decisions. Happy for all of you to connect with us at https://thetwig.com. Looking forward to seeing you again next time. If you like the video, do click on the thumbs up button and also click on the subscribe so that you are subscribed to any new videos that comes from us.